Hello everyone, welcome back for another video. We have been lost and finally we are back. For all your questions, we have been receiving them. We haven't answered most of your questions and we promise that now we are back and we shall be answering all the questions that you've asked. If you're there and you still have questions that you would want to ask, kindly send them via my email accounts, naomi.kangangi@gmail.com. Actually, I'll do it in the comment section so that you can send me the questions, and if need, I'll answer your questions, and if need be, I will do a video for you. So welcome back to all our new members here. Feel welcome. Here we do much of preparing students for exams. In case you have a question on whatever area that you are covering, just send it or write it in the comment section. I will be going through them and I will answer them. So there is a very common question that has been asked about the center line. Most students want to know how to find the center line of different kinds of buildings, and also specifically for the cavity walls. We want to know how to calculate the center line for the walls and the foundation wall, and also for the strip foundation, for all those areas. And now I want to introduce you bit by bit to centerline so that you can have a deep understanding of it, so that you can be able to calculate any shape that you're given. You can be able to find the centerline. So I will start from the very beginning. This is the first video for the centerline, and I will go into complex plans bit by bit. So keep tuned every day. We will expect a video, and we will be here to answer all your questions and also to prepare you for exams. For all those who have exams, we wish you the very best. We are here to assist you in whatever way that we shall be able to assist. That is why we are here. So we shall go straight ahead to discussing the centerline method. How do we calculate the centerline? We shall begin by asking ourselves, why centerline? Where did it come from? Initially, long time ago, when we were in our younger schools, for example high school, primary school, you were shown how to find the perimeter of a rectangle, and you are told that perimeter is equals to length plus width, you multiply by 2, the total of length and width you multiply by 2. So if you're given a rectangle which has a length of 10 meters and a width of 5 meters, the perimeter of that rectangle shall be, the length is 10 and the width is 5. So the perimeter shall be 2 into brackets 10 plus 5. 10 plus 5 is 15. 15 times 2 is 30. So perimeter of this rectangle is 30. What is the area? The area is equals to length times width. The length is 10 and the width is 5. So the area shall be 50. So you can find, you can see that finding the perimeter and the area of a simple rectangle isn't complicated. So it went a notch higher to finding the area of the shaded part. We have two rectangles here. We have the inner rectangle and the outer rectangle. The inner rectangle measures 8 meters by 3 meters. The outer rectangle measures 10 meters by 5 meters. So when you're told to find the area of the shaded part, what we do is calculate the area of the external rectangle minus the area of the internal rectangle. So the external rectangle, the area is 10 times 5, and the internal rectangle is 8 times 3. So finding the area of the shaded part is 50 minus 24, that is 26 meters squared. Now whenever we are doing center line, especially for example we are doing a wall, you can see a wall is usually like this shaded part. It usually has a thickness like this rectangle. The shaded part has a thickness of 1 meter. Now when we are doing walls, if you want to find the perimeter of this rectangle, the shaded part, assuming this is the wall, the shaded part is the wall, and you want to pay a contractor for constructing that wall, how much will you pay him in terms of how many meters will he have constructed the perimeter? Now that is where I want to introduce you to this other rectangle here. It's the same one, just like this one. We have it here. We have 10 meters by 5 meters external, and the thickness is 1 meter. When we want to pay a contractor for constructing this wall, we shall measure from here up to here. From here up to here is a distance of 10 meters, and from when we measure this area from here up to here, we shall have paid from this end to this end. So when we are coming to measure the width, we shall not repeat this area because it's already paid for. We have already calculated. Do you remember this is the thickness? This 1 meter is the thickness, assuming it's a wall. So because this is the thickness, we have already paid for this length, 10 meters. Now we shall pay from here up to here. So from here up to here, this one was 5 meters. We shall subtract 1 meter here and 1 meter here. So from here up to here is 3 meters. Then we shall measure again from the end to the end, which is 10 meters. Then we shall come and measure from here up to here. So the total will be 10. The length, let's look at this one. The length shall be 10 times 2. From here 1 and 2, 10 meters. Then we go to the width. The width from here up to here is 3 meters. 3 meters times 2. Remember, the reason why we are not taking 5, I want to emphasize for those who have not yet seen very well, we are not taking 5 because once we measure from here up to here, we have measured 10 meters of the wall. This one is the thickness of the wall. So if we take 5, we shall have repeated this area which we have already measured already. So the length shall be 20 meters, the width shall be 6. So the total perimeter shall be 20 plus 6, which is 26 meters. What is the total area? The area shall be the total, the perimeter of this wall that we are paying for, we multiply by the thickness, and that's where Centreline came up. Instead of taking 10 plus 3 plus 10 plus 3, we can just find the Centreline. The Centreline is this broken line that you can see passing in between the thickness of the wall. How do we find the perimeter of that broken line? We shall start, for example, we shall check length. Length was 10 meters. If you can look closely, this line it doesn't go to the end. It ends at the center. So if the thickness was 1 meter, it goes a half a meter into the wall, then a half a meter into this wall, a half a meter into this wall, a half a meter into this wall. So to find the center line, we shall take the length is 10 meters. 10 meters minus 10 meters is the external. So we are coming inside by half a meter by half a meter. 2 times half a meter. So the total length shall be 10 minus 1 meter, shall be 9 meters. We go to width. Width is 5 meters. We are coming inside by half a meter, half a meter. 2 times half a meter, 1 meter. So 5 meters minus 1 meter, 4 meters. The perimeter of this broken line, which is the center line, shall be perimeter of a rectangle is equals to 2 into bracket length plus width. If the length is 9 and the width is 3, so the perimeter shall be 2 into bracket 13. So the total perimeter shall be 26 meters. So what is the area of this wall all around? We shall take the center line, that is the broken line, then we multiply by the thickness of the wall. The thickness of the wall happens here to be 1 meter. So we shall get an area of 26 meters squared. So that will be the total area of the wall. So you can see there are so many different ways of finding a center line. We have seen this method whereby we were taking the external minus the internal, which is a bit cumbersome. Then we came to the other one here, which was taking the length, measuring length bit by bit from here up to here, then from here up to here, taking segments until we cover the whole wall, bearing in mind there's a thickness. Then there is the other one whereby we just find the center line. So I will be taking you through these two main methods of finding the center line into details, and you will be able to understand how we use them while taking off. So now, centerline is adopted for walls of similar cross sections. Centerline, we only find centerline for walls that have the same cross section. So someone may ask, what happens to those walls that have different cross sections? Maybe they have different footings, maybe the width of their footings are different. What we do, especially where we have internal and external walls having different thicknesses, cross sections generally, we find their center lines separately. We find center lines of the same walls separately from the ones that are different. So how do we use center line? Center line, we use it to calculate area. When we are using area to calculate using center line to calculate the area, we take the center line times the thickness. Or if we are using finding the volume, we shall take center line times the thickness times the depth. In case you're given such a rectangle, this rectangle here, we are given the length of the center line and we're given the width of the center line. You can see the length of the center line is 9.2 meters, the width of the center line is 4.2 meters. What is the length of the center line? And we have said center line is this broken red line passing in between the thickness of the wall. So we shall take the length 9.2 plus the perimeter plus the width 4.2 plus 9.2 plus 4.2. We get the total perimeter. And the total perimeter passing in between the thickness is what we call center line. And here we shall get 26.8 meters. So when we are talking about center line, this is simply what we mean. You can see this red line, broken line, we are saying it's a center line. It's a line passing through the center of the thickness. When we are finding a center line, that's all that we are looking for, so that we can take the center line times the thickness to get the area of the wall, or we can multiply by the thickness times the depth to get the volume of the wall. I hope that is clear. So if we have a rectangle like this one, now we want to introduce another concept. You can see that at the corners here, you can see here we have a corner here, another corner here, and another corner here. If you look closely, this red broken line passing through the thickness of the wall, as compared to the external dimensions, we are taking the external dimensions minus half the thickness this side and half the thickness this side. We take the external width, we subtract half the thickness this side and half the thickness this side. So the simplest method that is found out for calculating center line, we shall take the external perimeter, then we subtract four corners. You can see number of corners, there are 4. Then in these 4 corners we have 2 half thicknesses. We have 2 half thicknesses. Half width, it's half, as in half the thickness. For example, in this area 80 centimeters is the thickness. So we shall take the external perimeter for example for this one shall be 30 meters because the length is 10 and the width is 5. 2 into bracket length plus width, 2 times 15, 30. This 30 we subtract 4 corners multiplied by 2, 1, 2, half thicknesses of the wall. Half the thickness is 40. So 2 times 40 over 100, it shall be 2 times 0.4, 0.8. 0.8 times 4, we get 3.2. So the total center line shall be 30 minus 3.2, 2.6, 26.8 meters. This one is the same as taking the number of corners times the full thickness. Why the full thickness? Because this one we have half the thickness, half the thickness. So if you take 2 halves of the thickness, we shall get full thickness. So a simpler one, we can take number of corners, we multiply by the full thickness of the wall. In our traditional method of finding the center line, assuming it is a contractor who was constructing this room and it was measuring 10 meters by 5 meters, we shall come and mark here that this wall is up to here, noting that this one is the thickness, and it's up to here, noting that this one is the thickness. On the length side, the other side, it's up to here. The wall starts from here to here, and the other one, it starts from here to here. So in case we are measuring, I want to highlight this will be the wall. This wall we shall have measured 10 meters is for this wall. When we talk about 10 meters, it's for that wall up to at the end. For the other length is up to here. I hope you can see 10 meters is up to here. Then for the width, we shall take 5 meters. 5 meters was from end to end. But now we have subtracted this thickness because we have already measured it on the length side. So 5 minus 0.8 on the upside, 0.8 on the downside. So it shall be 0.8 times 2 is 1.6. So 5 minus 1.6. And we shall get, we multiply by 2 because perimeter is 2L, 2 width. So when we add 2L plus 2 width, we get 26.8 meters. So you can see this one is the same as the center line that we have calculated using the corner method. So the total area, we shall take the center line times the thickness of the wall. We get 21.44 meters squared. So for this diagram here, it shows this half thickness that we usually subtract. In case we are using external dimensions, we usually we subtract at every corner 2 halves of the thickness. So it's the same as 2 halves. It cancels out to be 1 times the full thickness. So when you're finding centerline, now we have discovered a new method. You can take the external perimeter, then you subtract number of corners times the full thickness for a regular rectangle. Now we go to another example whereby they are trying to show us when we use the external perimeter, we subtract the number of corners times the thickness. So let's prove it on this one. This one I got it from a book. I'll be able to guide you on what books you can use so that you can be able to learn more about takeoffs and center lines and such. So for this one, with the length of the rectangle was 15 meters and the width was 6 meters. So and the thickness of the wall is 255. So to get the external perimeter, we shall take the length 15, the width 6. So the total for length and width 21. We multiply by 2 to get the perimeter 42. Then we subtract number of corners times the thickness of the wall. So 4 times 0.225, 1.020. So the mean guard of the wall shall be external perimeter minus, we deduct number of corners times the thickness of the wall, get 40.98. To prove the answer, we use the traditional method of finding center line that we are very aware of. So you just reason, in case it was a constructor doing this room, we shall say we are measuring from here. We measure this wall up to the end. We measure he has constructed 15 meters. Then we come to the width. For the width, we shall start measuring from here up to here. Then we start again for the length from here up to here. Then for the width, we shall start from here up to here. So the total length shall be 15 times 2, which is 30. The width, we shall take 6 minus 0.255 on the upper side and 0.255 on the lower side. So we multiply by 2 to get 10.980. So the total center line shall be 40.980 meters. So you can see the answer is the same. Taking the internal dimensions now. We are given the external. First we find the internal. The external is 15 meters. We deduct the thickness of the wall, this side and this side. 0.55 multiplied by 2. We deduct from 15, we get 14.490. For the width side, we shall take 6. Then we deduct this side and this side because we want to get the internal width. We get 5.4. 14.490. What is the perimeter of the internal rectangle? It is 14.490 plus 5.9490. We get 19.980. We multiply by 2 to get the perimeter, which is 39.960. So 39.960 is the perimeter of the internal rectangle. How do we get the center line if we have the perimeter of the internal rectangle? We shall add, we are going to the outside, we shall add number of corners times the total thickness. The total thickness is 0.255. So what we shall add is 1.020. So to get the center line, we shall take the internal plus number of corners times the total thickness, and we shall get 40.980. So what about buildings of irregular outline? A regular rectangle usually has 4 corners, like this one, something like this, a regular rectangle. But if you see this one, it has more than 4 corners. So how do we find the center line of this one? How many corners do we have? We have 1, we have 2, we have 3, 4, 5, 6 corners. Now we want to find the center line, and we are given the external dimensions to be 20 and 9. So using the method that we have already learned, we shall take the external perimeter, then we deduct number of corners times the thickness. Now that we have external corners like these one, the ones that I'm highlighting in yellow, they are external corners on the outside. 1, we have 2, 3, 4 corners on the outside. The ones we call external corners. 5. We usually take the external corners minus the internal corners to get the number of corners. We take number of external corners, there were 5. We subtract the number of internal corners, it was 1. So how many corners do we have? We have 4 corners, and we shall be multiplying it by the total thickness of the wall. We get 1.020. So the total center line, we shall take the total perimeter of the outside. Note that the length shall remain to be 20 here, and 20 it is here plus here. You see, so it's 20 times 2. Then the width is 9 made of this one and 9 made of this full one. So it is 29 multiplied by 2, 58. Then we deduct, because it's the external perimeter, we deduct number of corners times the thickness. We get 56.98. Let's use another book to confirm how we should be able to calculate the center line. If we're given a regular rectangle, and so that we can be able to know how do we enter these dimensions into the takeoff sheet. So if this is the takeoff sheet, remember it has these 4 columns. We do the calculations in the description column. All the waste calculations, we do them in the description column. So we are given the length of this rectangle to be 10 meters. So what is the total length? It shall be 10 times 2, 20. Then the width is 8 meters. It shall be 8 times 2, 16. So 20 plus 16 shall be 36, the external perimeter. Then to find the center line, we shall take 4 number of corners, we multiply by the thickness. Here they had used the long method, whereby we had said, if you look at this diagram here at the corner, this diagram here, we are trying to explain, we shall deduct a half of the thickness on each corner on the length side, and a half of the thickness at each corner on the width side. So 2 halves will be deducted at every corner. 2 times a half. So how many corners? 4 times the full thickness. So the total deduction shall be 0.8. So the total center line shall be that 5.20. So so you can see they're saying at a corner we lose 1 times a half the thickness in each of the 2 directions. So 2 directions are half the thickness. So we end up losing a whole thickness at every corner. This is repeated in all 4 corners. If you want to prove this method, we always say that you can use the traditional method of finding the center line, whereby you measure from this end. You will say that this length is measured from there up to there, 10 meters, and from here up to here 10 meters. So the width shall be measured from here up to here. The width shall be measured from here up to here. So 10 times 2, 20. Then we add this. The width was 8 from end. Yes, the external one. Now we are looking for the one that we shall pay. 8 minus 0.2, 0.2. So 8 minus 0.2 times 2. 0.2 times 2 is 0.4. 8 minus 0.4 multiplied by 2, we get 15.2. So the total center line should be 35.2. So you can see that 5.2 is the center line. Proven. Okay, let's look at a rectangular plan shape with a recess at the corners. If we have a recess at the corners, we have said that the recess, how we shall find the center line? We shall count the number of external corners 1, 2, 3, 4, 5. Then we deduct the number of internal corners. Internal corners we have 1. So we shall take the external perimeter, deduct number of corners times the thickness. The number of corners is external corners minus the number of internal corners. External corners, there are 5, internal corner is 1. So 4 corners times the thickness 0.2. We shall deduct 0.8. What is the center line? So the external perimeter, we can see for this one, for this one is 10 meters, and for the length we have 10 meters made up of this one, then we take this one, so the length is 20 meters. For the width we shall take, it's from here, this one is 8 meters externally, then we have these 2 meters here marked with yellow, and these 6 meters here marked with yellow, so that it can form another 8 meters. So we shall get the total perimeter is 36. 36, we deduct 4 corners 0.2, 0.8. So we shall get the total center line is 35.2. So you can note that if a rectangle has a recess and the one that is regular, the center line is the same, because we have got 35.2 and the other one was 35.2. So rule number 1 of center line is a corner recess does not alter the perimeter of the shape. And this one explains why if a plan of a house has a corner, internal corner, the center line does not change. It is like the one that has a regular rectangle, and so the cost of calculating the walls shall end up to be the same. But this one that has a recess is a disadvantage, because some of the area is lost. If it was a regular rectangle, it would come this way, and it would have the same center line for the walls. So we shall have less space, same cost to calculate the walls. So, and also something else you should note, whenever we are putting the dimensions in the takeoff sheet and we are in the description column, we always put it to 3 decimal places. We only convert them to 2 decimal places when we are entering them in the dimension column. So I hope everything is clear. It was a long video. We have really explained a lot. In case there was any area that was not clear, kindly write it in the comment section. Ask any question. In case you have a complicated question which is in terms of a picture or something, you can just send it to my email. I shall be in the comment section. If you like this video, kindly give it a thumbs up. If you like this channel, kindly subscribe. We shall be keeping on bringing new content that will really help you in your exams. We shall answer your questions, and our main aim here is to prepare students for exams. So whenever you have anything that you want us to help, kindly reach out to us. So thanks for watching. Share our video, like it, share it to your classmates, and recommend us elsewhere. So thanks for watching. Bye.